Orifice flow meter. What we learn here, we will discuss about working principle, application, advantage and disadvantage, type of orifice meters like orifice plate assembly, integral orifice, restriction orifice. We will discuss some technical points, straight length requirement, technical specification and data sheets, vendor calculation review, dimensional drawing review, and about reputed supplier. In right side you can see there are the figure of orifice flow meter. So first figure is for orifice flow meter and second one is for integral types of orifice meter, where upper side it is showing the transmitter and this is showing the element part. Working principle of orifice meter. An orifice meter is a device used for measuring the rate of flow. Either it is liquid, gas or vapor. Orifice flow meter works based on differential pressure principle. By measuring the difference in fluid pressure between the upstream and downstream of the orifice, the volumetric flow can be calculated, and further it can be converted into the mass flow rate. So based on the Bernoulli's theorem, we can find the volumetric flow equation, which is Q is equal to C into A2 root of 2 P1 minus P2 upon rho. That means flow is directly proportional to square root of differential pressure. So Q is volumetric flow, C is orifice flow coefficient, A2 is the cross-sectional area of the orifice hole, and P1 is upstream pressure, P2 is downstream pressure, rho is fluid density, and whenever we convert volumetric flow to mass flow, then we have to multiply the density to volumetric flow. So we can get mass flow M is equal to rho into Q. Right side you can see there is a pipe. Inside the pipe there is a orifice plate, and this is the orifice plate hole. This is called orifice bore. Fluid will be passed through this orifice hole and go outside. So this high pressure area is called upstream and the low pressure area is called downstream. So there will be difference between upstream and downstream. Upstream pressure is called P1 and downstream called P2. The difference of upstream and downstream pressure is equal to differential pressure, which is P1 minus P2, and sometimes we denote with it delta P. So our orifice flow meter work based on differential pressure, so we require to measure the differential pressure so that we provide an orifice within the pipe so that there could be difference in pressure, and that differential pressure will be measured by the transmitters, and two tappings will be required for the differential pressure measurement. One is upstream tapping and second one is downstream tapping. So with this flow element we required a DP flow transmitter also to measure the flow. Application of orifice flow meter is natural gases, water treatment plants, oil filtration plants, petrochemical industries and refineries. It can be used for liquid, vapor, gases. Every cases we can use the orifice flow meter. There are various advantages of orifice flow meter, like that this meter is very cheap as compared to other types of flow meter. Installation direction possibilities is there. We can install vertically, horizontally inclined as required. No extra support is required because it have no much weight, so that directly we can mount on pipe. The operational response can be designed with perfections. Less space is required to install and hence ideal for space constraints applications. Very easy to install, wide range of sizes available for Orifice. However, we can see the Coriolis meter, magnetic meter, vortex meter have limited size of meter available in the market. But sometimes we require like 36 inch, 60 inch, 80 inch pipe sizes. Then we can use the Orifice meter in that case. Disadvantage: less accuracy than other types of flow meter. If we compare this TP type Orifice flow meter with magnetic, Coriolis or vortex meter, then we can find that the accuracy of this meter is less as compared to these flow meter. High pressure drop caused very high pressure loss. So this is also an disadvantage that this meter have high pressure loss. Straight run requirement. To accurate measurement, straight length is required. So this is a disadvantage because everywhere in the plant might be not available the straight run. Low turn down. The ratio of maximum flow to the minimum flow is very less as compared to Coriolis magnetic types of meters. Orifice plate can get easily corrode with time, thereby entails an error. In corrosive applications, we avoid to use the orifice meter because this orifice plate can be corroded with corrosive fluids. Hence, it can provide some error. So, we not recommend orifice meter in corrosive applications. Let's discuss about types of orifice meter. The first one, orifice plate. Second one, integral orifice. Third one, restriction orifice. So basically these three types of meters we can use in industry. Sometimes we require to measure the flow. Sometimes we require to restrict the flow. Sometimes pipe sizes can be more than 2 inches and sometimes it can be less than 2 inches. So in these various applications we can use orifice plate, integral orifice and restriction orifice as applicable. Normally more than 2 inches or equal to pipe sizes we use orifice plate assembly, where orifice plate assembly installed on the pipe and by the tubing we connect the transmitter and we can measure the differential flow. And whenever the pipe size is very small, we can say less than 2 inches, then the dp across the orifice is very less. Hence we required corner tapping and that can be done with integral orifice. So in these cases the integral orifice is preferred. So this is the thumb rule. If the pipe size is more than 2 inch, we have to use the orifice plate assembly, and if it is less than 2 inch, then we can use the integral orifice. Sometimes we not need to measure the flow, just we need to take the restriction on the flow because we want to drop our pressure. We want to kill our pipe pressure. So in that case we can use the restriction orifice. So here is the figure of all the three types of orifice. You can say this is the orifice plate only, this is the orifice bore, and this is the orifice handle, and this is the complete assembly where all the nut bolts, studs and well neck flange and orifice plate are there. Second figure is for integral types of orifice meter, where this is the pipe run and this is the flange and this is the transmitter sections. Sometimes we can purchase the transmitter with the meter run, but sometimes we can purchase only meter run and we can purchase this transmitter in from different supplier. Restriction orifice, you can say this is the cutway of restriction orifice, and this is the multi-stage restriction orifice. Here is the figure of restriction orifice, you can see. So this is the flange, this is the meter run, and inside this meter run there could be different plates will be there according to the requirement, because how we can reduce the pressure from higher value to lower value. So maybe it could be various stages like 2 stage, 3 stage or 4 stage. So we require multiple types of plates inside this meter run. Orifice plate assembly. So what are the parts of orifice plate assembly? You can see there is a jack screw to align this orifice plate, and these are the nut required. The number of nut will be as per the ASME B16.5 plate flange. So then stud is required to connect this orifice flanges, and then this is the tap plug. There will be 2 pair, 3 pair or 4 pair tapping will be there as per requirement. So if there is spare taps, then we have to plug them with SS plug, so that the tapping will be plugged, so our fluid will not pass through. Then gasket. For leakage avoiding, we require 2 gasket. One is upstream side to the orifice plate, and second one is the downstream side. So these 2 gasket will be required, and in middle this is the orifice plate. And then this is also a flange. Again there is the tap plug, and this is the bolt, and a nut will be required here also. So this is the complete assembly of orifice plate. Whenever we will purchase, then this complete assembly we require to purchase. Sometimes these flanges and assemblies like nut, bolt, stud, these are in piping scope, but normally we consider these in instrumentation scope. So we have to purchase this all in one requisitions. These complete assembly installed here with the pipeline. You can see this is the first flange, this is the second one flange, 2 upside tapping, this one the tapping, this is also tapping, 2 below tapping. All the tappings are plugged. You can see this is the plugged, and this nut, bolts and studs, these are the mounted over here. So you can see these 2 flanges is tight, and that inside this flanges 2 gasket and 1 orifice plate is there. So this is the complete installation of orifice plate and assembly, and this is the pipeline. This will be the pipeline, and this flange is called weld neck flange. This weld neck flange will be welded with the pipe. This is the figure where you can see this is the plate, this is the gasket, this is the weld neck flange, this is the joint assembly, this is the plate one only. Orifice plate type. Orifice plate have different types of design like square edge, quarter circle or conical entrance, centric and segmental. Most commonly used orifice plate is square edge orifice plate, and as per the standard ISO 5167, we can use this plate more than or equal to 2 inches pipe sizes. The beta ratio can vary 0.2 to 0.75. We will discuss about this beta ratio in detail after a few slides. Accuracy, we can get less than 0.5% of full scale flow rate, and repeatability 0.1%. So this is the square edge, and the edge, you can see these kinds of edge will be there. So this design is intended for general application with clean services for liquid and gases. Quarter circle or conical entrance orifice plate is used for the best choice for liquid with low Reynolds number. So as per the ISO or TR 15377, this is also used greater than 2 inches pipe size and the beta ratio 0.1 to 0.3 for conical entrance and 0.245 to 0.6 for quarter circles. Accuracy is less than plus minus 2% of full scale flow rate and repeatability 0.1%. Eccentric orifice plate. For the measurement of two-phase flow, dirty particles laded media. However, for small pipe diameter and eccentric plate is better solution than other like segmental. So greater than 4 inches pipe sizes and in dirty and solid particle contains processed media, we prefer eccentric types orifice plate. For measurement with two-stage and dirty and particle-laden media also, we consider this segmental types of orifice plate. So as per ISO or ASME standard greater than 4 inches pipe sizes, we can refer the segmental orifice plate for two-phase or dirty and solid particles contains processed media. So commonly used orifice plate is square edges. So in most of the cases you will see we prefer square edge orifice plate. Generally we do not prefer in dirty or solid content applications because there will be some choking chances will be there for the orifice plate and we will not get much accuracy. So we not prefer in dirty or solid contents media applications. We can go with different types of flow meter. So widely used the square edge orifice meter. Integral orifice meter edge. We have seen that less than 2 inches pipe sizes we prefer integral orifice plate assembly because the smaller sizes will have the smaller DP value. To measure the accurate DP value we require corner tapping and this can be done with a meter run assembly. It is called integral orifice plate. So this is the meter run, this is the meter run and this is the flange, this two tapping and you can see this tapping is just turned towards the orifice bore. So this is called corner tapping and this tapping is used for high pressure and low pressure and the direction of flow is called high pressure tapping and the downstream is called low pressure tapping. So by here we can get the pressure and the transmitter will be used to measure the differential pressure that will be converted into flow. So this is called integral meter assembly. Although sometimes we will purchase the integral meter assembly with transmitter also, but sometimes we can purchase only meter run assembly. Transmitter we can purchase from different supplier or we can purchase from loose. So this is only meter run assembly. Restriction orifice. So restriction orifice is used to reduce the pressure of the process media and it comes with single bore, multi-bore, single stage and multi-stage. Single bore means there will be only one hole on the orifice plate. A multi-bore means there will be multiple number of holes in the orifice plate. Single stage means there will be only one orifice plate to reduce or to achieve the reduced pressure, but sometimes the reduced pressure cannot be achieved with one plate. So we have to use multiple plate. So that is called multi-stage orifice. In multi-stage orifice plate, there will be more than or equal to two orifice plate and then they could be either single or multi-bore. So this is called restriction orifice, multi-stage multi-bore restriction orifice assembly. Here you can see 1, 2, 3 and 4 orifice are used. First orifice have this multiple bores, second one is also multiple bores, third one is also have multiple bores, but fourth one is only one bore. So different kinds of bore and different number of orifice plate can be used to achieve the reduced pressure. And these are the piping flange, like these are the flange with that will be connected with piping flange. So the gasket between this and piping flange, as the nut, bolt and stud will be purchased by the piping department. We have to purchase this complete assembly. So this is called restriction orifice. Some technical points we need to consider, or we need to know whenever we will work on orifice meter, like what is beta ratio, what is pressure drop, what is the straight length requirement, what is vena contacta, what is pressure tapping, orifice sizing standards, plate materials, assembly materials and flange rating. So let us discuss about beta ratio. Here right side you can see a graphical representation. This is the pipeline and this is the flow. This flow is going through the orifice plate, which is denoted by this red line. Whenever this flow will pass through this orifice plate, then its pressure will be dropped, so its area will be less. Again its drop pressure will be try to recover its original value. Somehow it will increase and it will achieve its original value, not 100%, but maybe some quite near to the original value it can get. So this is the downstream where the process will be flow. So this area is called upstream, this area is called downstream. So the value of the two pressure, upstream and downstream, the difference of the value is called differential pressure. So we are discussing about beta ratio. What is the beta ratio? So beta ratio is the ratio of meter bore and orifice bore, but the beta ratio is the ratio of orifice bore small d to the pipe id. You can say it's pipe id. So in short we can mention the small d by capital D. Small d is the orifice bore and capital is the pipe bore. So this is the beta ratio and it can be from 0.175 to 0.75. In between the beta ratio can be vary. Whenever we will do the calculations, then its value will be vary. So sometimes beta ratio will be more, sometimes beta ratio will be small. So there is some points also in beta ratio, like what will happen if beta ratio will be small and what will happen if beta ratio will be more. So if beta ratio will be small, then what happen? The differential pressure will be too high. So the differential will be pressure will be too high, that means the pressure loss will also be too high. So we will get the higher TP, higher pressure loss. That sometimes maybe process will not recommend, because process have always allowable pressure loss. So whenever we will reduce too much the beta ratio, then might be the calculated pressure loss can be crossed over the allowable pressure loss, which is not acceptable. And vice versa, we cannot increase the beta ratio too high, because whenever we will increase it too high, then the differential pressure will be small. That means if we reduce the differential pressure is too small, might be it is not able to measure the differential pressure by the transmitters, because transmitters have also some limitation to measure minimum differential. So that means we cannot exceed the beta ratio, also we cannot reduce the beta ratio also. So we have to consider the beta ratio in these ranges. The pressure drop, as I told you, that the downstream area the pressure is reduced, although it is try to increase its value, but it cannot get its original conditions. So the pressure drop is the difference of pressure of upstream and downstream. And what is the pressure loss? The pressure loss is the value of downstream pressure that cannot be recovered by the process. So this is the pressure loss. You can see this is the upstream pressure. Just to the orifice it will be down. Again it will try to recover its value, but it cannot be recovered its 100% value. So this is called loss. This cannot be achievable. So if this value is more than the allowable pressure loss which is provided by process, that means that meter cannot be suitable, because it will not follow the process energy mass balance equations. So we have to change our meter size, or we have to recalculate with different strategy. Straight length requirement. Process media have the different property of its flowing, like it can be have turbulent, it can be have transverse flow. That means its Reynolds number will be different. So as per the property of process media, we required straight length to change the flow property to the laminar flow. So as per ISO standards, we required straight length requirement for various types of installation. We will see later on. Vena contactor. What is vena contactor? Vena contactor is the point at the downstream where the pressure is very low at the lowest position, velocity at the highest position. So this position is called vena contacta, because here the pressure is low at lowest position, velocity at the highest position. Why it is important to us? Because if we take the differential pressure from this vena contacta, then we will get the maximum differential range. So that why sometimes it is required, like we can take the pressure taps from the vena contacta also. Pressure tappings. What is the pressure tapping? Pressure tapping is called the high pressure tapping and lower pressure tapping. It is called the connection of the process media which can take the fluid pressure to the transmitter, so that transmitter can measure the differential pressure. So sometimes we required flange tapping, sometimes we required vena contacta tapping, sometimes we required pipe tapping. Most commonly used tapping is flange tapping. Like our tapping will be on flange only, and the distance of tapping from the center of the orifice is 1 inches. So here will be flange, here also will be flange. So 1 inch away from this center line, both sides. So this is called flange tapping. And this D by 2 tapping is called vena contacta tapping, and other tapping is called pipe tapping. So as I told you, mostly we prefer the flange tapping. Either we consider the orifice plate assembly or integral orifice. So most commonly use the flange tapping, but in integral types of orifice meter, further it is called corner flange tapping. Orifice sizing standard is ISO 5167. So normally oil and gas industries, we prefer the ISO standards. So ISO 5167 is the orifice standards or DP flow instrument standards. So we can size our orifice, or we can consider the vendor sizing as per these standards. Plate material. Normally plate material available from different material, like stainless steel 304, 316, 316L, or Monal or Hestloy material. But generally we prefer the stainless steel material only, because for Monal types of material, the cost of the orifice plate will be too much. Sometimes we can use also, but normally we do not prefer. If the main reason for considering higher category of material is corrosion rate in the process media. So generally we not prefer the orifice plate in corrosive media. So we can go with the different types of flow meter because that have the higher accuracy with as compared to the orifice meter. So some special cases we can also use some higher grade of material, but in general we use stainless steel 316 or 316L. Assembly material. As we have seen that orifice, integral orifice or restriction orifice assembly is also there, but it is not required that the orifice plate and assembly will be of the same material. Plate material will be minimum stainless steel. We cannot use the plate of carbon steel. So plate have the minimum requirement of stainless steel, but assembly can be used of carbon steel as per the piping requirement. So assembly material can match the piping material. However, plate material is required minimum stainless steel. Flange. Orifice flanges. As we have seen that two upstream and downstream flanges is required to consider the orifice plate installations. So we consider weld neck, raised face flanges, and the size of flange will be depend on the size of pipe, and the thickness of flange will be depend on the rating of the pipe or rating of the flange. Minimum rating of the flange is 300. We prefer the minimum rating of a flange is 300 because we require the half-inch tapping on the flange. So how it is possible on the 150 pound rating of flanges, because its thickness will be not as much, so that we can take the half-inch tapping on the flange. This is the reason we refer minimum 300 flange rating in the orifice plate. However, if pipe rating is 600, then we have to consider the 600 flange rating. If pipe is 900, then we have to consider the 900 rating. But if pipe is 150 pound rating, then we have to consider minimum 300 pound rating orifice flanges. This is the straight length requirement as per the ISO 51672. So you can see these are the conditions, like two elbow can be on the same plane. This is the orifice plate, and you can see this is the orifice bore. So if the two single elbow will be on the same plane, so what will be the upstream straight length requirement and what will be the downstream straight length requirement? So that how we will consider the straight length requirement. So these are the criteria is there, and these are the value of upstream straight length requirement. This is the beta ratio of the orifice plate. So we will have the calculation, we will have the beta ratio during the calculations. So if you have beta ratio and if you have this types of installations like single elbow on the same plane, two elbow on the different plane, and these kinds of two elbow in the same plane and the two elbow in the different plane, so these kinds of scenario can be there. So in this different scenario, we have the upstream length A, like at zero point 0.2 beta ratio 3, zero point 0.4 beta ratio it is 3, and 0.5 beta ratio it is 9. So what is 9? 9 into D means from the orifice plate, 9 into pipe diameter. Suppose the pipe diameter is 100 mm, then 9 into 100 is 900. 900 upstream length we have to consider. There will not be any single or any elbow within the 900 mm above the upstream side. Then what will be the downstream length, straight length? The downstream straight length will be here. Like downstream length for all pictures or disturbance can be for 2D for zero point 0.2 beta ratio, 3 for 0.4 beta ratio, and 3 for 0.5 beta ratio. So we can consider this 3D at downstream and 9D at upstream. So sometimes we generalize these things, like we can consider the 10D to 5D, 15D to 5D as per these types of considerations. But if you go with this ISO 5167 specifications, then these straight length is required. However, we also refer the vendor's catalog, how they are recommended the upstream. Ultimately, vendor providing the final engineering, so we can consider as per their requirement also. But this is the very important parameters. We have to go with the 3D model also. We have to check whether this straight length is available or not. We have to check the isometric also, which is provided by the piping department also. So these straight length, pipe ratings, and flange ratings, and installation upstream, downstream, these things we have to verify with the isometric also. Technical specifications or data sheets. To purchase the perfect Orifice meter, we have to prepare the technical data sheet. In every engineering projects, we require to prepare this technical data sheet documents. Suppose if you have 200 Orifice meter in your project, then you have to prepare the 200 number of technical data sheets. So before preparation of technical data sheets, how you will prepare this? First of all, you require some input. So sometimes you need to refer the PNID. From the PNID, you will get some basic information. You required PDS, process data sheets. That will be required to do the sizing also. Vendor will do the sizing, so they will require some process data. Then we have to refer the PMS, like to know about the piping material, piping class, piping design conditions. We have to refer the PMS. So PMS is also will be required whenever you will prepare these technical data sheets. Then client flow meter specifications. If client have any specific recommendations or any specific requirement, then we have to refer the client specifications as well. So by reviewing this all 3-4 documents, we will start preparation of technical data sheet. Some general information we can fill, like tag number, service pin ID number, line sizes, and schedules, line MOC, and line ID. So these data we can fill from pin ID and PMS. Then the process conditions we will get from process departments. So normally flow, inlet pressure, outlet pressure, temperature, density, and for gaseous applications, molecular weight, specific gravity, these kinds of things will be required. And the design conditions, like minimum and maximum design pressure, minimum and maximum design temperature, viscosity, these kinds of things we require. And allowable pressure loss, this is very important, because whenever we will review the sizing calculation, then we have to check whether this calculated pressure loss is more than allowable or not. Then fluid nature, like it's toxic, corrosive, or erosive. So this is also this process data will be required during the preparation of technical data sheets. Then orifice plate assembly informations, like what is the types of orifice plate, concentric, square edge. The design standards is ISO 5167. Orifice plate material, so stainless steel 316 or 316L. But suppose the pipe material is stainless steel 316L, then we have to consider 316L. And plate thickness is, it is the vendor recommended. However, during the sizing it will comes over. Minimum straight plate thickness is 3.175 as per the ISO standards, and maximum it will be based on the size of the orifice and process conditions. Then beta ratio. Beta ratio is also dependent value of calculations. So during the calculation it will come over, like it will vary from 0.2 to 0.75. Vent and drain hole diameter. This is also required. Vent and drain hole also required sometimes. if your main process media is gas, then might be some unwanted liquid can be there. Vice versa, if your main process media is liquid, then unwanted gaseous conditions will be there. To pass through this unwanted items, we require vent and drain hole diameter. So if it is liquid case, then we require vent, and if it is gas application, then drain is required. So during the sizing calculations, you have to select this option to consider vent and drain hole diameter. So this will also calculated during the sizing. Orifice bore diameter, this is the calculated value. Whenever you will calculate, then orifice bore diameter will be calculated. Differential pressure we have to select. So to match the beta ratio, we have to select the differential pressure. This can be vary, like we have to vary the differential pressure to find a perfect orifice, like to consider the beta ratio, and by considering the calculated pressure loss value. So pressure loss and beta ratio will be as per the our requirement. In that case, whatever the differential pressure will be there, that will be the measurement range or calibration range for the transmitters. So normally what is the value we will use for the differential pressure whenever we will start the sizing? So it is called 25-inch H2O. So just start the sizing with 25-inch H2O, and we can vary this value depend on the calculated pressure loss and beta ratio. Similarly, the measurement range we have to provide for the transmitter, like what will be the display value for the measurement. So it is just we can multiply 1.5 or 1.3, 1.2 as per the requirement. Generally, we consider the minimum 10% of the maximum value. So suppose if your 100 kg per hour is your maximum value, so what will be the calibration or measurement range? It will be 0 to 1110 kg per hour. So by this way, like maximum value of the flow into 1.1, this will be the measurement range. Calculated pressure loss, it is the calculated value. So all the star values depend on the sizing. So as per the sizing, whatever the value we will receive, that we have to put here. Then we have to provide the information about flange, like what is the types of flange, size of flange, material of flange, flange finish, flange rating. So these all the value we have to provide. So weld neck 4-inch, 316, 600 and 125 to 250 ARH. Flange finish is required. Gasket size and material. So the size of pipe is equal to the size of flange is equal to the size of gasket, and material we can consider as per the piping material specification. Tapping size and locations. So normally 1.5 inch tapping is more than sufficient. However, in bigger size of orifice plate, we can also go through the 3 by 4 inch tapping, but minimum half-inch tapping is recommended. And both the flanges, at least one tapping is required. One is for high pressure tapping and one is for low pressure tapping. So minimum one pair tapping is required, but sometimes vendor provide multiple tappings, like 2 pair or 3 pair or 4 pair tapping. So all the spare tapping we need to plug it, we cannot consider it at open. So all the applicable tapping we can use, other or spare tappings we have to provide this stainless steel blind plug to cover it. And the transmitter's location will be either above tapping or below tapping, because if you are using the gaseous applications, then the transmitter's locations will be above the tapping, and in the liquid applications, the transmitter's location will be below the tapping. And also this is called tapping orientations. Like tapping orientation we can mention here also. So what will be the tapping orientation for the upstream? So we can consider the 45-degree up, and for the liquid applications we can consider the 45-degree down or from the horizontal line. So this way we can provide the orientation of the tapping. Straight length requirement is either vendor recommended, or we can go through the ISO 5167. Stud and nut and bolt material, it can be provided from the PMS, like we can refer the PMS whatever the material they are using, and that the same material we can also consider here also. So these some data from the Orifice plate assembly we can provide here, and if any other things if you want to provide, then the same things also you can provide here. But for Orifice plate material or Orifice plate assembly, these are the minimum informations we need to provide. When the certification is required, then we can mention here. Then the purchase data also we can mention here. So these all the technical terms and all the informations we can put in a format of any project document, that will be the data sheet of any Orifice flow meter. So similarly we will do this activity for the all the 200 number of tags, and that will be a particular deliverable for the Orifice flow meter. But remember, this is for the Orifice plate assembly only. Transmitter will be procured with different requisitions, so we have to prepare the different data sheets for the DP type flow transmitter. That will be covered in different lecture of transmitters. Vendor calculation review. So whenever we will prepare the technical data sheets, after approval we will send it for the inquiry. We will get the sizing, we will get the technical quotation from the different supplier. So we have to review these calculations. So some we have to check whether they are the technically acceptable or not. So during the review of the calculations, we need to check, sometimes we need to check the process data also very carefully, because might be it can be either by mistake it can be different value as we recommended in our data sheets. But sometimes also a vendor manipulate the data to match the board area or beta ratio or calculations calculated pressure drop also. So we have to check the process data very carefully. Then we have to check the what is the board area, what is the beta ratio, calculated pressure drop, and calculated pressure loss. These minimum information we have to check with the calculations. Same times we will compare the pressure loss at maximum flow to the allowable pressure loss which is provided in process data sheet. So if the calculated pressure loss is under allowable pressure loss, then that is there is no any concern. But if calculated pressure loss is more than allowable, then there will be concern. Either we have to check with the process department it is acceptable or not. If it is not acceptable, then we have to go with different types of meter, or we have to go with different supplier. So this 5 terms is very important during the vendor calculation review, like process data, bore diameter, beta ratio, calculated pressure drop at maximum flow, calculated pressure loss at maximum flow. Apart from these informations, if all these information are in line, then few informations also we have to provide in our data sheet during the PR preparation, like Reynolds numbers we can put there, and flow coefficient we can put there, uncertainty value we can put there, head loss we can put there. So these are the calculated value we can put in our technical data sheets after the finalization of vendor. Dimensional drawing review. Once our order will be placed and the size technical terms will be freeze, then vendor will provide the dimensional drawing for review. So during the dimensional drawing review, we have to know some basic things what we will check in the drawing. Like first of all, we have to check about the flange type. Whatever the things we have mentioned in our technical data sheets, that we need to check here in drawing also. Everything we have to verify from the technical data sheet to the dimensional drawings. like what is the types of flange, it is weld neck or not, size of flanged, rating. Also sometimes they provide the finishing also. Again we have to check the bore dia as per their sizing calculation and the dimensional drawing if it is matching or not. Again maybe they can provide the table for the beta ratio also, so that will be also good. We have to verify with the sizing also. Tapping size, like what is the sizing of tapping they are providing, like here you can see they have provided the 2 number per flange, half inch NPT flange taps they are providing. So if we are asking for half inch, then that is the good. So these things we have to check: type, tap size, tap type, tap locations, everything we have to check for the tapping. Again the plate type, material thickness, what is the thickness they are providing. So they will mention the thickness, material and size also. So size also we need to check whether they have wrongly they have provided the bigger size with the pipe or not, or it is okay. So these kinds of things we have to check. And also we have to check some information on the tag plate, on the handle, like as per the project requirement we required some minimum information, like it is provided the inlet, it is provided the bore size, it is provided the rating of the orifice plate and model number of the orifice plate, and design condition, design pressure, design temperature of the orifice plate, thickness of the orifice plate, material of the orifice plate. So these kinds of information can be mentioned on the handle, and wherever this information is mentioned, this that will be the upstream side. So this is also point of taking care. So these information we have to check during the drawing review. Also dimensions we have to, like face to face dimension, what is the vertical dimension is there. So these all the details we have to check they have provided or not. Again they have to provide the BOM, like nut, bolt, gasket, plug, meter and whatever the items we are purchasing as per our PR data sheet, that we need to provide, or that we need to capture in dimensional drawing also. So this will be the quite big document, and somewhere they have to provide the bill of material also with quantity and material. Again meter run means, suppose we are reviewing the integral orifice or multi-stage RO, so they will provide with meter run. We have seen in earlier slides also. So that straight length requirement and the face-to-face dimensions and spool piece length, all the details they have to mention. So we have to check these things very carefully. Some reputed supplier is there, like YKGIC, Emerson, ABB are in the market. We can purchase all the like integral orifice, restriction orifice from this supplier as per our requirement. Sometimes we purchase only plate, sometimes we purchase plate and assembly, sometimes we purchase plate with meter run, sometimes we purchase with transmitter also. So as per the project requirement or as per project strategy, we can purchase different kinds of things from the different supplier. So this is all about orifice meter.